Hi guys, I'm going to be showing you through this free response question, which is about ionization energies and what you can infer about an element from them. So, context, we are given the first 3 ionization energies from 4 unknown elements from the 3rd row of the periodic table. So, what we're asked to do first is to find the element that's most metallic in character. If you think about metallic bonds, you know they don't hold on to electrons very well. They just sort of float around freely. So we're going to want a low first ionization energy, and that makes 2 the best candidate with that 496. Part 2 asks us to identify element 3 and write its electron configuration. So take a look at those ionization energies for element 3. It has a relatively low first one, a pretty normal looking second one, and then a huge jump at the 3rd one. So that tells us a few things. If we think about Coulombic attraction, I'm filming right now, Kale. Thinking about Coulombic attraction, they have less protons to pull on their electrons. So as you go through the atoms, first ionization will gradually increase and decrease whenever you need to add a new shell to house that new electron. And that's the second factor, distance. In the formula, distance gets squared, so it matters a lot more. So this tells us a few things. So that relatively low first ionization energy tells us that it's towards the left of the periodic table. And that big jump in the 3rd tells us that it has 2 electrons in its outermost shell. If you want to get a periodic table, let's look over at magnesium there. I think magnesium's our best bet. See, it's towards the left. It's got 2 electrons in its outermost shell. So its electron configuration will be 1s2, 2s2, 2p6, 3s2. Now, parts D and E asks us to identify element 2 and find its expected oxidation state for its most common ion. So we can use a similar process to identify element 2 this time. You can see that really big jump in energy at the second one, so that means it only has 1 electron in its outermost shell, and that low first ionization energy suggests it's towards the left, so it's probably going to be sodium. See here, makes sense, right? Remove 1, it's back up there. And so sodium basically always ionizes to +1, so that'll also be its oxidation state, +1. So part F asks us to find the smallest, or which of these will be the smallest when they're neutral. So we only need to look at the first ionization energies for all of these. So as I was talking about before with distance, the closer something is, the more attracted it will be. So we want, again, something that has a very high first ionization energy. Looking back at this again. Oh look, element 1 with that 1,251 kilojoules per mole. Yep. Pretty cool, right?